Hey guys, is this working?
It is.
Oh, Ramin's still muted.
Yep.
Looks like I can't hear you. Hold on.
No, I'm unmuted now.
There, now we're working. Okay, great. Awesome. Well, hey everybody, welcome to the Weekly Space Hangout for Friday, December 19th, 2014. This is going to be our last episode of 2014, I suspect, unless something really strange happens. So let's make this a good one. Joining me this week, we've got Morgan Redberg. Hey, Morgan.
Hey, Fraser.
Your camera looks amazing today.
I know.
You look like you're in really high definition today.
I flew all the way across the country just to get to this camera for you.
So you're doing Christmas holidays now. It's begun.
That's right. That season is upon us.
Awesome. All right, and we got Dr. Ramin Skiba. Hey, Ramin, how's it going?
Pretty good. How are you, Fraser?
Good.
I'm still in San Diego. Haven't started my holidays yet.
Oh,
your camera isn't HD.
Yeah.
Yeah, I know. I need to get a new one.
Yeah, San Diego for the holidays has got to be pretty nice. That's about the nicest place I can think of right now.
Well, we'll be going to the Sierras, so that'll be nice as well.
That'll be great. Okay, cool. So we got a ton of stories now. We didn't do a show last week because I was in transit. So we got a ton of things to catch up on. We're going to be talking about the NASA budget, the discovery of methane on Mars, or further evidence of, the most distant large galaxy cluster, quenching star formation around black holes, the death of Venus Express, some updates on Indians launches, the Morpheus launch. We got a ton of stuff to talk about. So. We'll get into it. Now, before we do, I just want to remind everybody that this is a live show. You can interact with us. Lots of ways you can do that, but the best way is you can use the Q&A app, which is available wherever you're watching this on YouTube. If you click, it says Fraser is interacting with the audience, and if you click that, then you'll get another version of the window, and then there's going to be some places you can post some questions. So go ahead and post any questions there, any comments and feedback you want, and we will try and get that into the show. So I'm going to say hi to Nancy Graziano, Nathaniel Sanchez, Yov Landsman, Althurian Baltazan, Elad Avron, Pete Wall, Hugo Burnham, Giselle Saborin, Bert Walters, man, everybody's here. Thomas Traniker, Will Didoni, and Michael Jobin. So those are the crew that have showed up, and a lot of those names are very familiar. Those are the people who you can often find in the Weekly Space Hangout crew. My camera is really slipping down. The Weekly Space Hangout crew. So if you go to Google+, do a search for the WSH crew community. That's where a lot of the real diehard Weekly Space Hangout fans are, and you'll be able to interact with them and talk about the show and talk about your favorite space stories of the week. So it's a great place. All right, let's get cracking. So I think, man, lots of big stories. Let's start with actually the budget. This is going to be great. Casey Dreyer isn't here, which is really crazy to me. Casey Dreyer is our friend at the Planetary Society, and typically he comes to tell us bad news about NASA's budget. But now suddenly, the NASA's budget is all good news, and where's Casey? So instead, we've got Morgan, who is here to give us the good news. Morgan, what's happened?
Yeah, that's right. So over the last couple of weeks, the U.S. Congress managed to pass a $1.1 trillion spending bill to fund the U.S. federal government for the next 12 months or so, with a few small exceptions. And, of course, included in that was money to fund NASA. And NASA, as you said, Fraser, got a great budget this year, just in absolute terms, but also in comparison to some of the budgets they've had in the past years. Congress appropriated $18.01 billion for NASA this year. That's about $350 million more than they had this year in 2014. And more importantly, it's $550 million more than the president asked for in his budget. And this is kind of a trend that's been going on for the last few years. President Obama asks for a cut in NASA's budget every year when he submits his budget request to Congress, and every year Congress comes back and not only restores the money that he asks to be cut, but adds additional funding to that. And this is coming both from the Republican side and the Democrat side. The biggest winner in the budget this year is Europa. Europa gets $120 million earmarked for a mission development. And that's a huge increase over the $20 or so million that were earmarked last year for development of a mission to Europa. So NASA can take this money and use it as the seed to start what will hopefully be the Europa Clipper mission to launch in, say, a decade or so.
For those who aren't aware of what the Clipper mission is going to do, can you give just a quick overview on that mission?
Yeah, so Europa is one of the 4 big moons of Jupiter. And it has an ocean underneath its surface with more water than all the oceans on the Earth combined. And there's some evidence that there may even be geysers or plumes on the surface of Europa, just like we see at Saturn's moon Enceladus. And so what the Clipper is going to do is going to make a series of flybys around Europa and study not only its surface, but use radar to penetrate its surface and look for this underwater ocean. And it's going to enable us to map and understand Europa at a scale much, much higher than the last time we did this, which was going on 20 years ago with the Galileo mission, which was sort of a general Jupiter studying mission. This is the next big mission that's going to happen in planetary science, answering some really exciting questions about one of the most exciting places in the solar system. But to do that, we're going to need somewhere between $1 and $3 billion for this mission. Probably closer to $2 or $3 billion. And so this $100 million is just a drop in the bucket, but it's the important starting drop that gets design going, allows NASA to call for proposals, things like that, so that then we can get more funding to actually get the mission going.
Right, and if you look at the history of missions, you know, the most recent ones, things like the International Space Station, things like the James Webb Space Telescope, SLS, I mean, they've all come in dramatically over budget. You know, I think James Webb is up to $8 billion for its funding. So when it was originally intended to be somewhere in the couple of $1 billion range, and this is, you know, this kind of increased budget is going to help, I guess, deal with the reality of what these missions actually cost, as opposed to the fantasy, which is what people try to do to get them sold in the first place. So, go ahead, Ramin, you were going to say something.
Yeah, I was just going to add, so in addition to James Webb, there's also WFIRST, which is an infrared telescope that NASA's funding. And a big deal was SOFIA, which is an infrared telescope that's on an airplane. And that one was basically on the chopping block in the president's budget. But its funding was restored with the new budget that was passed. However, they may not be able to do all of the upgrades that they wanted to, but at least they'll be able to finish their mission. Also, there was a chance that the education and public outreach budget of NASA could have gotten cut substantially, but it seems like that was spared. There may be some restructuring of the budget in the Science Mission Directorate for Education, but at least that funding is still there.
And that's a part that hits pretty close to home because, of course, you know, the Weekly Space Hangout started as part of CosmoQuest, and CosmoQuest, a lot of its outreach is funded by NASA's education and science outreach funding. So a lot of the work that we're doing to get the, you know, to help communicate space and astronomy and help get people excited and enthusiastic about the missions and things like that, some of it is actually funded by NASA. And I know Pamela, Dr. Pamela Gay, my co-host on Astronomy Cast, is constantly in this state of fear and anxiety about what's going to happen with her budget. So this is, I think, hopefully this is going to be really good news to her and the rest of that team.
It does sound like good news on the education side.
Yeah, and it's crazy to me, right? Because NASA just has such a fan following. 8 million people follow them on Twitter, millions on Instagram. They get just enormous goodwill. I mean, it is the best publicity the U.S. government could be putting out right now, and so I'm glad they recognize it and they appreciate it, and they're contributing to support it. So.
One other budget thing was that the National Science Foundation also got a slight increase in their budget, and they fund, for example, the planned Large Synoptic Survey Telescope, which will be the successor to the Sloan Digital Sky Survey, and will observe millions of galaxies. And so that's great that their budget was basically not substantially affected.
Yeah, and that's going to be really good for your work.
Yeah.
Yeah.
Absolutely.
Okay. Well, good. Was there anything else on that?
Yeah, just across the board, NASA saw increases. The three main fields that NASA works with, planetary science saw a 12% increase, astrophysics, that's Hubble and James Webb, 13% increase, and then human spaceflight with the Space Launch System and the Orion capsule saw a 19% increase. So Congress is not really directing NASA in one direction here. It's saying go forth and keep pursuing all of these different goals, and that's what we want to do.
Nancy Graziano says, I can't help but wonder if President Obama is beating Congress at their own game by requesting a cut in NASA funding, knowing full well Congress would do just the opposite of what he asked, just to spite him. So that's brilliant.
Well, it's not entirely accurate. So actually, he had a sort of supplemental funding thing, which would have filled in some of the gaps. It was something initiative. I forget what it was called, but basically Congress said we're going to have nothing to do with that. And so those cuts were in place, and then Congress restored part of the funding that was in there. So it's kind of like this back and forth, I guess.
Yeah. No, I know, but it's like reverse psychology. That's all. You know?
Yeah.
He's just saying like, no, let's cut space, and they're like, we'll do the opposite of whatever Obama says.
If that actually worked, I think he'd be applying that to all sorts of his life problems right now.
Yep. So just watch, see if he uses that strategy again. But okay, cool. Good. Well, why don't we move on then? I guess it's sort of we'll move on to a different story, and then we'll come back around. I want to talk about quenching star formation around black holes. And Ramin, you were following the story.
Sure. Yeah. So it's so every galaxy at some point forms stars. That's how it grows, and you have every galaxy has some structure in its stars as well as its gas, but it's really the stars that we see. And so the problem is that if you look in various models for how galaxies form, if you use a sort of a simple version of the model, you'll end up forming galaxies that are too big compared to what we see. The galaxies that just are more massive than what should be out there, or there's too many galaxies. And so what people have thought might be a solution to this problem is that some process is shutting down this star formation, or quenching it, as they say, and that could be feedback or some sort of energy given off from supermassive black holes at the center of these galaxies. And so the galaxies that we observe that are so there's this black hole at the center of this nearby galaxy. It's called NGC 1266. It's relatively nearby. By that I mean I think it's 100,000 light years away, or no, wait, 100 million. And it's a lenticular galaxy, or S0 as we call it, which means that it's a disk galaxy, but with a bulge dominated a bulge component, and at the center of that bulge is this black hole. And so in this galaxy, it looks like the energy from the black hole is in the process of giving off this energy with its jets and shutting down the star formation. So eventually, this galaxy's star formation rate will go down. The reason why this is important is because this is a debate that's been ongoing for decades. Basically, is what is making these galaxies stop their star formation and become the quote-unquote red and dead galaxies that we see out there. And some people think it might be due to black holes. Other people aren't so sure. And this seems to be evidence for at least some galaxies shutting down their star formation this way.
But wasn't one of the ideas that the supermassive black holes would be firing out material in their jets, and that this infalling material would help do the opposite, would help actually trigger star formation, that it would, because a lot of star formation happens when, say, the supermassive black hole shock waves, when there's supernova shock waves that move through clouds of cold gas and begins that collapsing, and that this could be another mechanism that could start that process from happening.
Exactly. So it's more complicated the way I described. So less massive galaxies, supernova feedback. So the explosions from supernovae are the primary process that slows down the formation of stars. And these massive galaxies, supernovae are not sufficient. But you're right that what will often happen, especially if you have, say, merging galaxies, you may have a burst of star formation in part of the galaxy that has the black hole. And so you may have sort of an increase in the star formation rate early on. But then as what happens is this feedback energy from the black hole will heat the gas so that it's not able to collapse and form new stars. And so in the long run, the star formation will be shut down, unless some other galaxy full of gas comes by and merges with it, and then the process can continue again. But barring that happening, then the galaxy is, quote-unquote, red and dead, as they call it.
Red and dead. Are these the sort of the massive elliptical galaxies, or are these? Yeah. Okay.
Yeah. So this galaxy, a lenticular, an S0, is sort of like a precursor to an elliptical. So it's like an elliptical galaxy surrounded by a disk. And so, for example, in the process of a merger, that disk could get completely disrupted, and then it'll be like an elliptical.
And so you could call this a dying galaxy. This is the point where
the
star formation wraps up, and now it's just old red. All the new stars are gone, and then you're just left with the little red dwarfs, and they just last for 1 trillion years.
Yeah, it sounds sad, but that's the universe for you.
That's the universe. The universe doesn't care. All right, the universe wants you dead, so let's be clear. Okay, well, let's move on. So let's talk about, speaking of NASA, Morgan, you put this story in, and I actually mentioned this as well. NASA built a useless tower, and it doesn't want it anymore. And I'll try to dig up a picture of it.
Yeah, that's right. So Congress can do great things for NASA, but they can also do really stupid things. And we just try to minimize the stupid things they do versus the great things that they do, but this is one of the all-time dumb ones. So if you remember back 8 or 10 years now, President George W. Bush was in office, and he had this plan that we were going to go to the moon, go to Mars, and beyond. And we were going to do it on the back of a brand new rocket system called Constellation. And Constellation was basically last year's version of the SLS, the Space Launch System. It was going to carry our next generation crew capsules, etc., out there into space. But development wasn't going well for NASA. It was very expensive. It was over budget. And in 2010, President Obama canceled the Constellation program and replaced it with the SLS program that is continuing to this day. But when that happened, not all the pieces of Constellation were able to get canceled along with it. And the big one that didn't get canceled was this enormous tower basically, for testing rockets in vacuums to simulate the vacuum of space. And so with a huge new huge new Constellation rocket, they needed a huge new tower to test it. And they had two options. They could either build a new tower, or they could refurbish the tower that was used to vacuum test the Saturn V back in the Apollo era. And somehow, when they ran the numbers, they came up with the notion that refurbishing the Apollo the Apollo chamber would be more expensive than building a whole new chamber from scratch. And so they set out building this new $350 million vacuum chamber in Mississippi designed to test the Constellation rockets. But when in 2010 Obama canceled Constellation, the senators from the state of Mississippi forced into the legislation a provision that required NASA to complete this test tower. And so this week they finally completed that test tower, and they immediately mothballed it. So it will never be used for any sort of science. And worse yet, they now have to spend $700,000 a year in perpetuity to maintain this building in a mothballed state. And so really, we've, not only have we basically shot one of our toes off here, we're not allowing ourselves to put a bandage on it. We're stuck now. NASA's stuck spending almost $1 million a year maintaining this test facility that they don't plan to use and that they never have used. And it's just an example of how this budgeting process can go very wrong. Here we're celebrating the fact that NASA gave $120 million specifically to develop a Europa mission. But if we didn't like the idea of a Europa mission, we'd be here groaning that they had meddled with the NASA budget and made these specific requirements. And so the moral is really the less direct commands, basically, that Congress can give NASA, the more efficiently the space agency, or really any government agency, can use that money, and you get less of these projects that end up just being basically the space equivalent of a bridge to nowhere.
maybe they could turn it into a roller coaster or something. Like it seems
Kind
like
of looks like it from that picture.
yeah, it looks like an impressive facility. Like maybe experience 30 seconds of free fall in a vacuum or something, right? You could go in there, put on a spacesuit. They could evacuate the atmosphere, and you could fall. And then
Sounds like fun.
yeah, and then somehow get caught at the bottom or something. But I mean,
Drop
that's
some feathers and see how fast the
but I mean, but it's surprising to me, and I'm sure people have brought this up, that there's no use for the SLS. I mean, there's a whole. I mean, Constellation was canceled, but that doesn't mean that the idea of heavy rocket systems aren't being used. And the SLS is, I mean, the SLS is using space shuttle style booster rockets, but still, there's got to be some value for this thing.
Yeah, hopefully in the future, if they need to, for example, vacuum test the heavy launch SLS, they won't build a third vacuum chamber.
Right.
That would be sort of insult on top of injury here. And instead, they could use this brand new facility they have to actually perform those tests. And if not that, maybe that they can sell it to SpaceX or
SpaceX.
something like that to use for a similar capacity.
Yeah, they could test the Falcon Heavy in there or something. Maybe the Indian heavy rocket is maybe they could do some testing with that one, or the Chinese. The Chinese are working on a new. Yeah, the Chinese are working on a new heavy lift rocket. They're going to be launching, I think, in 2028. So perhaps they might be able to rent space in it, time in it. I just open it up and let anybody use it, right? Like just let any of these people come in and bring your rocket in and do some tests in the zero gravity. I think it'd be good. They can make money from it. Put me in charge. Come on, make some money from this. All right, let's move on. Next up, methane on Mars. Let's talk about the methane on Mars, and then we'll go to another one for Ramin. So, Morgan, you've been following this?
Yeah. So there is, in fact, methane on Mars. And this is something we've expected all along because there are a lot of natural processes that create methane, and we see it other places in the solar system. For example, Titan is just chock full of methane. But we've never been able to find it with spacecraft. The Viking spacecraft didn't find it. The Mars exploration rovers, Spirit Opportunity, they couldn't find it. There'd only been one purported detection of methane, and it was made about 5 years ago from an observatory here on Earth. And the amount of methane they claimed to detect was very small in comparison to the amount of methane in Earth's atmosphere. And so you can see what the problem with this would be. If you're trying to look through 100 tons of methane to find 1 ton of methane, you better be pretty sure you know how much methane's in the Earth's atmosphere in order to screen that amount out. And so nobody really believed that we had a firm detection of methane on Mars. But with Curiosity, we were able to send a suite of instruments, the Sample Analysis at Mars package of chemistry labs, that were far more sensitive than anything else we'd ever had there before. And they announced this week that Curiosity has in fact found methane at Mars. And it found a more interesting situation than perhaps we would have initially imagined. So basically, as a baseline, Curiosity found that there's about half as much methane on Mars as we normally would have expected, given the amount of rocks and minerals and things on the Martian surface. But every few months, that amount spikes up by a factor of 10. So you go from having half as much as we'd expect to having 5 times more than we think should be possible. And then it ebbs away, and then we see another spike a few months later. And this process seems to be cyclical. And that's about all that we know. We don't have a good understanding for why this could happen. Somehow methane must be being created underneath the surface and then released in pulses, basically, in a time scale of months. Whether this is an organic process or an inorganic process, we don't know. It's far more likely that this is an inorganic chemical process going on underneath the surface than the idea that there's life every 3 months releasing a bunch of methane into the atmosphere.
But if you observed Earth, you would see something kind of similar to that. You would see life, the amount of carbon dioxide and oxygen in the atmosphere changing, pulsing as life was going through the various seasonal phases. So, I mean, is it?
No, that's absolutely true, and this is, undoubtedly probably the strongest evidence that you could hold up in favor of the idea that life could be still living on Mars today. Because methane on Earth is definitely dominated by natural processes, by life-based processes. But that doesn't mean that there aren't inorganic ways of creating it, and certainly both of these avenues will be explored going forward. And it shows us either way that Mars is much more active today than we thought. It's not just that it's leaking away gas for billions of years to leave the thin atmosphere it has today. No, it's still producing methane and other gases within its surface, and it's not even doing it at a constant rate. It has this cyclical nature to it. And this is just one more exciting aspect of a much more dynamic Mars than we would have thought even 10 years ago.
So what would it take then to get to the bottom of this, right? To figure out the source? Would it be about mapping the methane with a really high resolution to try and see if there's a place where it's being outgassed, and then try to, I guess, investigate those areas? It keeps coming back. Like, we don't know if it's if it's life. We don't know if it's just some volcanic process. What will it take to get to the bottom of this?
Yeah, so certainly mapping it out and finding the source vent would be the most important first step. And the good news is that source vent must be close, because methane in Mars's atmosphere should stick around for hundreds of years. And yet, like weeks after this pulse, it returns back to this baseline level. And what that tells us is that the methane's being released close to Curiosity, and then dispersing out across the rest of the planet and basically diluting back to the baseline level every few weeks or months. And so, somewhere nearby, maybe even within Gale Crater, where Curiosity is located, is the source of this gas. Because otherwise, if this was being released everywhere across the planet at once, then you wouldn't expect to see it die back down to this baseline level. Okay. And so, if we could drive Curiosity around and basically take measurements, at various locations, you could try to triangulate the source. But we'd have to be able to traverse a larger distance than we can do with Curiosity, and we can only make a measurement every 3 months. So it would be a pretty tedious process at this point. I don't know if now that Curiosity has raised these observations, whether, say, MAVEN from Mars orbit will be able to make a map and sort of track down this. I don't know if that capability exists or not, but that's what you'd want to do, is find the location first, and then that might be the sort of place that you want to send your next mission, or even the place you'd like to send the first humans to Mars, because now we have a credible location where something unexpected is going on the surface, and that's exciting.
Yeah, but I guess up until a couple of years ago, it felt very, very cut and dry to me. Like if they were able to detect serious amounts of methane, that would be really the smoking gun, that there is life there that's producing it. But it seems like what they're finding is stranger than they were expecting, and getting at an answer is going to be even harder than they were anticipating. And so it just makes this search for life just that much more frustrating. And yet it's kind of in our grasp, but it's still a little out of our reach.
Yeah, that's absolutely true.
Yeah. All right, well, let's move on. Still super exciting. Let's talk about the most distant massive galaxy cluster today.
That's right. So far. When you think of galaxies, you might think of an individual galaxies located in different places, but actually the majority of galaxies are in groups, as in a handful of them, and then the most massive systems, which are very rare, we call them clusters. And so then you might have dozen, hundreds, or even thousands of galaxies, all in a gravitationally bound system. And so if you think of dark matter and the cosmic web, these are also the densest parts of the universe. Now, galaxy clusters, we see a lot of them at low redshift, as in the relatively close by universe, but at higher redshift, so further in the past of the universe, these clusters basically haven't formed yet. You either find only groups or unbound systems that you think will, at some later time, form into a cluster, and so we call those protoclusters. However, a bunch of scientists, so from Italy and Germany, France, and the U.S., using NASA's Chandra X-ray Observatory, observed the most distant massive cluster, so not just a protocluster, which they dubbed Gioiello, which is Italian for jewel. It seems like cluster people like to name their clusters. There's the Bullet cluster, El Gordo, and now there's Gioiello. And so this is it's at a distance of about 9.6 billion light years, which puts it at about 100 times as far away as that galaxy with the black hole we were talking about before. So this is pretty far away, and it's pretty exciting. So it's because these are so rare, it's an interesting result to have to find a cluster this far away. Because basically, if you find clusters that are too far away from a modeler's perspective, from a theoretical perspective, that means these clusters have to form very early in the universe, and so then we need to figure out how does these structures form at this time when in the beginning the density perturbations are so small. So it takes a long time to it takes time to form a galaxy and then a group and then eventually form a cluster with thousands of galaxies together. But this Gioiello sounds like an interesting system with a variety of galaxies in it, as you saw in that picture, in that image. The first author of the paper, which is now accepted in the Astrophysical Journal, is Paolo Tozzi, if you're interested in looking it up for more.
And so I guess what's unusual about this is just that you're finding a galaxy cluster that's this massive this early on in the age of the history of the universe, when normally we don't see clusters that large until much more recent.
Exactly. So there are more massive clusters, but they're all closer than that one.
Right.
And so yeah, this is exciting for how early in the universe this cluster has formed.
Well, theorists, I'm sure this overturns theories of galaxy formation.
Well, there's always a way to, tweak some theory to make it work.
Yeah. Okay, so a couple more things, then we'll move on to the WSH crew suggested stories. One is we were going to be talking about SpaceX, but now that's been pushed back. So, Morgan, you've been following the SpaceX launch delays?
Yeah, so we were hoping that, by now, today, we'd be able to tell you that SpaceX had successfully landed the first reusable rocket basically ever. But because of some problems that they were having with the rocket prior to launch, they've pushed that launch now past the holiday season and into early January to make sure that they resolve all those problems before they carry up supplies to the International Space Station. And of course, this supply run is especially important, given that the last one was aboard the orbital Cygnus rocket that failed last month. And so they want to make sure that they get these supplies up to the astronauts in time and get them up intact. And so they've pushed this launch back. But when they do launch, it's going to be an exciting opportunity, because the last few launches, we see them extend these legs and try to sort of come down to a halt right above the ocean's surface. But then a wave comes along and grabs them, and into the ocean they go. There's no way for them to just stay there forever. This time, they're going to tow out a landing barge, basically, with a landing pad on it, and they're going to try to touch down on this pad. And this will prove that they have the ability to land basically on a solid surface, and they can do it in the most difficult circumstances, because you can imagine trying to land on a pad that's pitching and rolling in the ocean, far more difficult than trying to land on a launch pad on land. And because of that, they're not giving themselves real, high hopes of succeeding on this first try. They're saying less than 50-50 chance that this works, because in the past with this landing attempts, they've been happy if they could land basically within a 10 by 10 kilometer box of where they wanted to go. But in order to land successfully this time, they're going to need to land basically in a box that's 10 by 10 meters. And so we're talking about an improvement of 1,000 in the precision of the landing between their last attempts and this one. And they've demonstrated with the Grasshopper reusable rocket that this works. But they Haven't yet tried it in the ocean, coming down from space with the big Falcon 9. And so whether or not it works this time, it's an important step forward to making it work eventually. And once they can land smack in that white circle, then the Air Force will allow them to start returning to Cape Canaveral and landing on the ground.
Okay.
And then the next part of the process begins, and that's looking at the rocket and figuring out, can it fly again? We've never actually seen a rocket that flew to space and back without having gone through the ocean. So we don't know what kind of damage the components are going to have. If it turns out that you're going to have to replace 50 or 60% of the components in between flights, then this idea of reusable rocketry is going to take a big hit. But if the engineers look at this and they determine that you only need to replace a valve here or a tank there, then you have the idea that, yes, it's cost effective to be able to return your launch stage back to the ground and put a new capsule on top.
Well, and it's a whole new way of building rockets, that they're going to now be looking at a rocket in the same way that aircraft maintenance crews look at their aircraft. They know how many miles an airplane can fly before you're going to need to reservice this part, this set of valves, or how long you're going to need to swap out that rotor. And it's sort of the same thing, that they're going to launch this thing, it's going to land, they're going to take a look at how it did, they're going to be able to start working out a maintenance schedule, they're going to fix the parts of the rocket that tend to wear down or the parts that are failing, and they're moving ever incrementally towards this idea, right, that the rocket launches, the bottom stage comes off and then returns to the launch pad, and then the next stage peels away and maybe launches somewhere downrange, maybe at an alternative launch pad, and then all you're left with is the cargo that goes up into space, and then all the parts are reassembled, and the rocket is refueled, and the rocket takes off again. This is hard, and it's going to fail a lot, and they're going to learn a million new things. But if this works, then this changes everything. Everything.
Absolutely. And it's harder than you probably are imagining. SpaceX described this landing attempt as trying to balance a rubber stick on your finger in a hurricane. And that's, the forces not only acting on the spacecraft, but then here also acting on the landing pad, and then having to get those lined up while hurtling down from the edge of space is just an unimaginable challenge. And so even if it takes 5 or 10 tries to succeed, just succeeding once and being able to move on is going to be an absolute win. No matter how many loses they have first, one win is what they need to move on. And it might take a while, but it's going to be worth it 100%.
Yeah, and landing on the floating platform is probably going to be harder than landing back on the ground, right? The nice safe ground.
Absolutely.
The stable location where you can be off a couple of 100 meters and still land safely if they make a big enough landing pad.
Yeah, the Air Force, I think, gave them requirements of landing in a 1 kilometer by 1 kilometer square area. But SpaceX wants to set its standards higher to make sure that it's always exceeding, for safety reasons and reliability reasons, what the minimum requirements are. And so they're aiming for a launch pad that's basically 100 meters by 100 meters. And of course, then you got to hit the middle of that or you'll fall off into the ocean.
That's crazy. Okay, well let's move on then. So let's move to the portion of this show. Oh, I guess there's one last story. Well, we'll talk about this as part of this. So we'll move to the show where we talk about the stories proposed by the folks at the Weekly Space Hangout crew community on Google+. And so every week they're just talking about space stories all week long, and we big thanks to Nancy Graziano, who is sort of one of the administrators of that. She plucks out a bunch of the stories that they've talked about, and we sort of talk about them as well. So first, this story comes from Jim Meeker, and this is the fact that India was going to launch its new heavy lift rocket, and they ended up doing so. So India tested out its heavy lift vehicle this week, the GSLV Mark III, carrying a capsule that might eventually hold astronauts. Morgan,
so this rocket's about twice as powerful as the previous Indian-built rocket, and initially it's going to allow them to launch much larger communication satellites, similar to the ones that we have here for our various satellite radio, satellite television, satellite internet, etc. and this will enable India to do that homegrown. But it's meaningful that the payload that they launched on this first test was not a communication satellite, but the prototype for their crew capsule. In a lot of ways, this is very similar to the Orion launch from a few weeks ago, where they basically launched this prototype crew capsule and then brought it back down through the atmosphere to test how it withstood re-entry. And this is India basically working to match China in the human spaceflight arena. China's been launching people and in their own Chinese-built spacecraft now for about a decade, while India has been focusing more on robotic unmanned exploration. They've gone to the moon, they're now going to Mars, or they're at Mars even now. And so these two countries have taken slightly different paths to exploring space, but both of them are also taking the other path. China landed the U-2 rover on the moon, and now India is developing their own space capsule that will allow them the ability to ferry astronauts to space, just like Russia can today, and just like America is working back towards acquiring that capability.
Yeah, and I mentioned this earlier on in the show. China has announced that they're working on their heavy lift vehicle as well. I think it's the 9. I forget the name of the Chinese launch. What are they called? The Long March. So I guess it's called the Long March 9 is going to be their one, and they hope to have it running in 2028. But I mean, they've announced a pile of things. They're sending a rover to Mars. They're going to be, they just did a flyby of the moon, so they're going to need these heavy lift vehicles. But it's amazing, right? So many options. The Indians are going to have a heavy lift vehicle. The Chinese are going to have one. The SpaceX has got the Falcon 9. There's the SLS. There's the Ariane 6. Just 5 years ago, there was nothing heavy that could get anything into space. When you think about what they had to do with Cassini, they had to do all of these crazy orbital flyby maneuvers to get it up to have enough speed to get out into the outer solar system. And now suddenly we've got all these heavy launch options since now the space shuttle's out.
The prospects didn't look so good a couple years ago, but now it seems like there are a lot of options that these space programs can use.
Yeah. And then, ironically, the capabilities of the spacecraft, it's all the miniaturization is going crazy. So you've got these CubeSats, and then you've got these fragments of CubeSats. So I mean, you can launch a satellite that's not much bigger than a Kindle that can do some basic science, which is just amazing. So it's a funny time. You've got these enormous rockets with these ever decreasing and more efficient payloads. Good times. All right, let's move on. Okay, so compact. This was suggested by Helga Björkog, which is a compact galaxy group revealed details of close encounters.
So this result is related to the one I talked about before about galaxy clusters. But with galaxy groups, there's sort of like smaller systems where you might have a handful of galaxies in one system, and then they're bound together. But there are some galaxy groups where they're more compact than you might expect, and so that has to do with their. So we think that has something to do with their assembly history, like how they form, also with the dynamics of the galaxies in them, and so there's a team led by Iraklis Konstantopoulos who observed some compact groups with the dark energy camera. And what they're able to see is it looks like tidal tails from galaxies. And so when you see galaxies pass nearby each other, they exactly. And so you can see sort of a galaxy get stretched out in a way. And so a tidal interaction creates a tail like this. And so they think that this could be an example of a tidal interaction between two galaxies in this group. And so we think, and it seems to be confirmed, that these sort of interactions and even a merger of two galaxies are common in groups, in some groups anyway, and these groups seem to be an example of that. That they also have a result that involves fossil groups, which is sort of the end result of this situation, where what you have is you have two galaxies that or maybe more than two, that merge together, and you end up with a group where one galaxy is much more massive or luminous than the rest of the galaxies in the group. And that galaxy is sort of like they call it fossil because it sort of tells you about how the thing formed from over the past few billion years before that. There's no such thing as a fossil cluster. This only really happens in groups, and so it's an interesting result.
Got a couple of quick questions from the audience. One, the next VSP is when? So when is the next virtual star party happening? We don't know. We put them on hold because they were so complicated and everybody was getting burnt out and it was really hard. So we went week after week after week where none of the astronomers could show up. So Scott and I talked about some new ideas for how we do the virtual star party, getting access to some cameras, like iTelescope has a virtual telescope that we can use, and there's the good folks at the Night Skies Network. So we're looking to reformulate a plan and maybe in the spring. But so thanks for your patience. Apologize, but it just was falling apart. So it wasn't working for anybody. So we need to come up with a new idea. Here's a good
talk
one.
about Morpheus.
Yeah, so we'll talk about Morpheus for 1 second, but this comes from Hugo Burnham. What's the difficulty ratio for landing SpaceX on an ocean-going platform against landing a Philae on the surface of a comet? Morgan, what do you think?
Oh wow, that's comparing apples to oranges if I've ever heard one.
Yeah, exactly. Space apples to galactic oranges.
The biggest difference probably is that Philae was falling at, like centimeters per second, while the Falcon 9 is desperately trying to slow down from thousands of kilometers per hour. And so you basically have two inverse problems. SpaceX, you're trying to slow down as quickly as possible. With Philae, you have lots of time. You just have to make sure that you're in the right place when you get there.
And that your harpoons are working.
Right. So I wouldn't want to be in charge of landing either of these. I have no doubt that both of them will, and one has already landed successfully at some point. But I would not want to be the person in charge of either of these processes.
Especially with people on board. Like, I think when we think about a human mission to visit an asteroid and attempt to mine it, like this idea of human asteroid miners now just seems like, with what happened to Philae, it just seems crazy difficult and dangerous.
Yeah.
Yeah, people have a big advantage over computers, which is that they can see things and anticipate things and take that kind of action. Yeah, in real time. And that kind of leads us right into this project Morpheus story, because NASA is attempting basically to solve the Philae problem with something like this. So I don't know if you want to
let's talk about the Morpheus test that happened yesterday.
Yeah, so Project Morpheus is an unmanned sort of hopper lander type vehicle that's being tested here on the Earth, and it has two major goals. One of them is pretty boring. That's to develop a new kind of environmentally friendly rocket and rocket fuel. It's great for our environment. It's critical to do. It's not going to give us capabilities that we don't already have in terms of where we can go and what we can do. The other part of it, though, is to develop autonomous navigation, basically. So this is basically the three-dimensional version of your Google self-driving car. It uses lasers to map the area around it, and it has algorithms and things built in designed to avoid collisions and make decisions about where a safe place to land is. And so it took off, it hovered, it moved around, and it landed again, all under autonomous control. And this is a big step forward. And maybe some of you have seen the old Apollo era video of Neil Armstrong trying to land the trainer for the lunar module. And the thing is just bucking and hewing back and forth, and he ends up having to eject out, and it craters off into a field. Controlling these kinds of things is incredibly difficult. And it's a perfect job for computers. We just need to teach them to do it. And that's what Project Morpheus is doing, and it's making progress in teaching landers like Philae how to realize things aren't right and to take action basically to correct the problem in a way that maybe, wouldn't be the most obvious initial way to correct the problem.
Right.
By the way, if you're wondering, as I was, Morpheus is named after the Greek god of dreams, not the Matrix character.
Right. Okay, so one last note. I just want to mention this. It's kind of sad, which is that Venus Express is going to be is pretty much done. So it's been 8 years, its mission, and it's sort of the plan now is that they were going to have it do sort of, or they're going to have it deorbit into the Venusian atmosphere, and now the European Space Agency has lost contact with the spacecraft itself, and so the atmospheric descent is going to happen, as expected. It's going to be doing sort of an uncontrolled re-entry and just get smashed up in the atmosphere. So they lost contact November 28th. So at this point,
Did they
see you later?
Hopefully they were able to obtain some data from it before they lost contact.
Yeah, so they tried to raise the altitude around that time, but they weren't able to get contact, and it looks like it is out of gas. So they're not sure when it's going to die, but it's going to happen in the next few months. And I guess with the other spacecraft, with Cassini and with Galileo, scientists were quite concerned about whether you would infect the planet, or perhaps you would land. They're worried about Cassini ending up on, say, Enceladus and infecting Enceladus with earthbound microbes. I don't think they have to worry about that with Venus. Venus is just like an autoclave as an entire planet. So I think any microbes sent to Venus are done for. So, yeah, because as we said in today's, we released an episode of our video, The Guide to Space, this week, and the gist was Venus sucks. It's just the worst. Like, let's just push it into the sun and be done with it. So let's wrap this up. Let's give people a way that they can find out more about what it is that you do. So, Morgan Renberg, where do people find out more?
Yeah, well, right after the show, you can find me over in the Google Plus Space community. Just go to plus.google.com, click Communities, find Space, and I'll be answering any questions or chatting about anything from the last couple of weeks that we didn't get a chance to talk about. After that, you can find me on Twitter at Morgan Renberg. I'm trying to be a little bit more active there. And you can always visit my blog, cosmicchatter.org.
Fantastic. All right. Ramin, where do we find out more?
You can find me on Twitter at Ramin Skiba, and my blog is called Science Political. It's at raminskiba.net. I actually plan, if I have time, to write a post about the budget situation for NASA, NSF, DOE, Office of Science, and all those science-related agencies. And then also my website at UC San Diego has a lot of I describe my research and my publications there. And if I can successfully, fingers crossed, successfully submit a paper on the evolution of the spatial distribution of galaxies, I will post that on there soon too.
Right on. Okay, and once again, I'm Fraser Cain, publisher of Universe Today. You can find me on Twitter, right there, fcain, and I've been putting a lot of effort into Twitter recently. So I've been using it as a place to dump out all of the cool stories and stuff that I see that we're not necessarily going to report on Universe Today. So it is like I am curating what I think is the coolest thing. So if you want a cool Twitter feed to follow me on Twitter. Of course, as well on YouTube, where we're posting 2 new videos every week on our Guide to Space series. This week, what was it? What does space really look like? No, why is space black? Which is where we talk about the Olber paradox, and why is Venus so horrible? And there's a bunch of great topics coming up. So we're just closing in on 150 episodes of this now. So.
Wow.
That's great.
And then as well, if you want to support what I do, you should check out my Patreon page. So go to patreon.com/universe today, and you can contribute a couple of bucks, even 1 penny. Right now, you can contribute 1 penny. You'll never be charged, and you'll get all the ads removed from Universe Today. You'll get access to all the secret behind-the-scenes stuff, all the extra bloopers that we do. So you just go to patreon.com/universe today, and we're going to be wrapping that up shortly. So now's your chance. Cool. Okay, so thanks to everyone for watching. If you haven't already, go check out the Weekly Space Hangout crew community on Google+. Just go to WSH Crew there. If we don't do another show for the next couple of weeks, I hope everyone has a wonderful holiday and a great new year. We've got some very cool and exciting guests that are going to be coming next year. So I will, when we're able to announce it, I will let you know. So thanks everyone for watching. Thanks to Morgan and Ramin for joining us this week. We really appreciate it, and we will see you all next time and maybe next year.
Happy holidays.
Happy holidays.
Happy solstice.
Right on.